Good morning everyone. Now let's start the revision of the chapter, that is the HaloAlkanes and HaloArenes. HaloAlkanes and HaloArenes. We have already discussed various properties and various things about the HaloAlkane and the HaloArene. Now let's discuss the one of the important property of the HaloAlkane and the HaloArene, that is known as the nucleophilic substitution reaction. Now this is a very important topic, nucleophilic substitution reactions. This one is the very important topic. This category is under the topic reaction of the HaloAlkanes. So under the category of the reaction of HaloAlkane, there are three types of reaction. The one is nucleophilic substitution reaction, second one is elimination reaction, and third one is the reaction with metal. But the most important is the nucleophilic substitution reaction. So in this type of a reaction, a nucleophile react with HaloAlkane. Now here the HaloAlkane act as a substrate having a partial positive charge on the carbon atom, bonded to the halogen. A substitution reaction takes place and the halogen atom is known as the leaving group and it depart as a halide ion. Since the substitution reaction is initiated by a nucleophile, that's why it is known as nucleophilic substitution reaction. Now the nucleophilic substitution reaction is of two types. The first one is known as that is SN2 reaction. SN2 reaction. This is the first one, SN2 reaction. It is also termed as a substitution, as stand for the substitution, nucleophilic, and here the digit 2 is used. That one is the bimolecular. Bi means 2. Substitution nucleophilic bimolecular reaction. Now let us take the example. For example, we have CH3Br. Now OH minus is the nucleophile. We get CH3OH plus Br is, this one is eliminated. Now this one is the methanol. This is bromide ion. This one is the bromide ion. This is the bromide ion, and this one is known as hydroxide ion. This OH is known as the hydroxide ion. Now the reaction between the methyl bromide, this CH3Br is the methyl bromide. So the reaction between the methyl bromide and hydroxide ion to form the methanol. This is the methanol. The product is methanol. Follow a second order kinetics. This whole reaction follow the second order kinetics. Now the meaning of the second order kinetics is the rate depends upon the concentration of both the reactant. Now here two reactants are, one is the methyl bromide and second one is the hydroxide ion. So the rate of this reaction depends upon the concentration of both the reactant. That is why, because the rate depend upon the two, that's why it is known as the bimolecular. So the rate of reaction may be, if we want to express the rate of this reaction, so the rate of reaction is expressed as, that is the rate is equal to K. The first reactant is CH3Br and the second one is OH minus, that is the hydroxide ion. So in fact methyl, that one is the CH3 is the methyl or the primary alkyl halide. This one is the methyl halide or the primary alkyl halide. Follow this type of mechanism and it may be written as, and if we want to write a general expression for this reaction, so we can easily write that rate is equal to that is K Rx. This is for the representation of alkyl halide, and here the hydroxide ion is same. Now in this reaction, here two molecules take part in determining the rate of reaction. These two molecules, one is this one and another is this one, they take part in determining the rate of reaction. So it is termed as the nucleophilic substitution bimolecular. That is the nucleophilic substitution bimolecular, and this type of reaction takes place. This type of reaction is nucleophilic substitution bimolecular reaction occur in a single step, though the formation of a transition state. In this type of a reaction there is a formation of a transition state, but the reaction occur in a single step. Now let us elaborate the reaction, this one reaction. So now let us elaborate. So for example, we have that is CBr. This is the bromide group present here. One H is here, one H is here. These are the hydrogen. Here we have CH3. Now we have hydroxide ion. This one is plus. Now what happened in this reaction? This bond is broken down, this is eliminated, and this one is attached to this one. So this is a 1 degree alkyl halide. This is a 1 degree alkyl halide. This is the back side. This is the back side attack. This is the backside attack of the nucleophile. Now what happens in the next step? There is a transition state where C, the position of CS3 is same. Now this bond is broken down between the carbon and the bromide, so it acquires a partial negative charge because its electronegativity is very high in comparison to the carbon, and this OH part is attack this one. This is the backside attack, this is attached to this one. Now the position of this hydrogen is same and this hydrogen is also same, and this is known as transition. This is transition state. This is the transition state. This state is the transition state, And in the next part of a reaction, we have C, the position of CH3 is same. Now Br is detached from the carbon. Now this one is the one hydrogen, this one is the another hydrogen, and this OH is attached to this one, and this is the Br minus, and now it is eliminated, so it is a leaving, this one is the leaving group, this is the leaving, this Br is the leaving group, and this is the alcohol. So this is the mechanism, of the nucleophilic substitution by molecular. Now in this reaction we are talking about this complete reaction. In these reaction, bond making occurs at the same time as the bond breaking takes place. Now the breaking of the bond and the making of the bond. Now look at this transition state. This shows the breaking of the bond, and this is the making of the bond. So here the breaking and the making of the bond occurs at the same time because the two events occur in a concert. So we called it as a concerted reaction, and that's why it is a nucleophilic substitution by molecular. Now this reaction occur in a single step. Only the main thing is that there is a formation of this transition state, otherwise the reaction completes in a single step. That's why it is known as the SN2 reaction. Now the next type of the nucleophilic reaction is known as the nucleophilic substitution unimolecular. Nucleophilic substitution unimolecular, and it is also represented as that is SN1. This is the SN1 reaction, also known as the nucleophilic substitution unimolecular. Now the meaning of SN is clear, that is the nucleophilic substitution, and the meaning of the one, it says that the rate determining step is unimolecular. One stand for the rate determining step, that one is the unimolecular. So in the nucleophilic reaction, two steps are involved. One, in this type of a reaction, two steps are involved. One is the removal of the halogen, and second is the attack of the nucleophile. Now for example, we have that one is R, this is the alkyl group, X, this is any alkyl halide, plus nucleophile. So what happened? At one time this one is eliminated, and the second step is this one is attacked to the alkyl group. So this is the reaction. Now what happened? That is RNU, this nucleophile is attacked to the alkyl group, plus X is removed as a leaving group. So the situation in both the steps takes place one after other, that is the two steps takes place in this reaction. In SN1 reaction, the two steps takes place. Now let us elaborate the steps. So what happened actually? This is the C, this one is the halogen. Now we have three alkyl group attached to the carbon atom, so it is known as the 3-degree alkyl halide. This is a 3-degree alkyl halide. Now what happened? This is now this one is left from here. This is the first step. The first step is the removal of the halogen. Now we get C. This one is R. Here we have R. These are the alkyl group. Plus we have X. This one is the leaving group which is eliminated from this direction. Now it is a step. This is the step 1. Let us consider it as a step. This is the step 1. Now this step is a slow step and it is considered as a rate determining step. This step is a slow step and is considered as a rate determining step. Now here the carbon contain the positive charge and it is termed as a carbocation. This is termed as a this is the carbocation. This one is the carbocation. Now this is the first step. Now let us talk about the second step. Now what happened in the second step? In the first step we have seen that there is a removal of halogen. Now in the second step means the attack of the nucleophile. Now let us see how the nucleophile attack. So in the next step we have C. This is the next step. This one is the R. This is the R. These are the alkyl group. So now we have two conditions. This nucleophile and here this is the nucleophile. Now the two conditions means now this nucleophile attack to this alkyl halide from two directions. The first direction is this one and the second direction is this one. These are the two directions and this step is very fast. First step is very slow. That's why the first step is known as the rate determining step, but this step is very fast. Now let us consider this step. Now these are the two steps. So this is the A1 and this is the B1. This is the A1 route and this is the B1 route. Now let's categorize them A1 and this one is the B1. This is the A1 route and this one is the B1 route. Now what happened? Let's discuss with the first one. We get such type of product when the nucleophile attacks from the route one direction, that is here, that is this one is the nucleophile. This is the nucleophile. So this one is the position, and if the nucleophile is attacked with the B1 direction, so we have C. These are the alkyl group R. This one is R, this one is R, and this one is NU. This one is NU. So these are the two way. The first one is the route 1, that is the A1, and the second one is the route 2, that is the B2. So these are the two different product. These are the two different product. Now this one product is known as, inverted. This is known as inverted product, and this product is known as, this is known as retended. This is known as retended. This is known as the retended product. This is the inverted product and this one is known as the retended product. Now, what is the difference between the inverted product and the retended product? So, in case of the inverted product, the attack of the nucleophile, this is the direction for the attack of the nucleophile. The attack of the nucleophile and the removal of the halogen, that is X, takes place in opposite direction. Now, this one is the, this is X, this is N, U stand for the nucleophile. Now, this is the direction of the removal of halogen and this is the direction for the addition of the nucleophile. So, in case of the inverted product, the attack of the nucleophile, this is the position, this is the attack, this is the way of the attacking the nucleophile and the removal of the halogen, and this is the way how the halogen removed, this is the way. So, these are in the opposite direction, that's why it is known as the inverted product. And now, in case of the retended product, the attack of the nucleophile, now here this is the position of the attack of the nucleophile, this is the direction of the attack of the nucleophile and the removal of the X, that one is the removal of the X, takes place from the same side. Now, the position are same. Here the attack of the nucleophile takes place and here the removal of the X takes place. That's why it is known as the retended product. So, nucleophile attack from two sides. In this case, the nucleophile attack from two sides. Product are similar only in the orientation or the arrangement is different in space. If it in SN1 because reaction depend upon the concentration of one reactant only. Now, here the second step, this one step is the second step. The first step is the removal of the X. This is the attack of the nucleophile. So, this is the second step. We also discussed that the removal of the X is the slow step. It is a rate determining step. But the addition of the nucleophile is the fast step. This one is the fast step. So, the second step is the fast because it involved the attack of the positive and the negative entity. So, the first step becomes the rate determining this step. This removal, this become the rate determining step. So, this is the main topic of the HaloAlkane and the HaloArene. Now, we have already discussed about the that is the chiral carbon atom. We have already discussed about this topic. Now, enantiomers, if we want to talk about the enantiomers, so the isomers we get with the different orientation, the orientation is different, that is known as the enantiomers. So, there are various topics and the various reaction of the HaloAlkane and the HaloAlkane and the HaloArene, but the main topic is the nucleophilic substitution reaction. Now, one of the another important topic of the nucleophilic substitution reaction is that is called the Setziff rule. Now, let us discuss the Setziff rule. Now, that is the next topic, that is Setziff rule. So, in case of HaloAlkane, HaloAlkane can eliminate hydrogen halides in two different ways. Then that alkene will be preferred in which the carbon atom joined by the double bond are maximum alkylated. Now here the meaning of the alkylated means contain the maximum number of the alkyl group. Now let us discuss it with one example. Now this one is the, now let's start numbering the hydrogen. This one is the hydrogen, this one is the H, this is the another, this is the hydrogen. Now here we have also, this is H, this one is H. Now here we have, this is H, this is X, and again we have, this one is H, this one is H, and this one is H. Now this carbon atom is considered as a alpha carbon atom. This is considered as a beta carbon atom. Again next to the alpha is beta and next is gamma. Now why we consider it as a alpha carbon atom? Because the carbon atom which contain any other atom other than the hydrogen or the carbon is known as the alpha carbon atom, and next to them is beta in this side, and here again in this side we have the beta, and then next to it is the gamma. Now we have the two method for the elimination of the hydrogen halide. Now the first way is we eliminate the hydrogen halide from here. This is the first way, and the second way is we eliminate the hydrogen halide from here. So we have two ways to eliminate the hydrogen halide. Now halogen combined with both the beta hydrogen atom. Now we have the two product. So let us consider, this is the first case and this one is the second case. This is the second way to removal, the way of removal, and this is the first way of the removal. Now by this method we have two product. So in first case, if we are talking about the first case, so the product of the first case is, that is CH3, because carbon, this is the carbon 1 2 3. Now one hydrogen atom is eliminated, so we have only one hydrogen atom is here, so we have CH. Now this is eliminated, so we have here the double bond. Again, yeah, here we have CH, and at last we have CH3. So this is the way, this is the product which we get from the for removal of the hydrogen halide in the first case. Now if we opt the second way, that is the hydrogen is from here and halogen is from here, so we have CH3, CH2, CH double bond, CH2. So this is the second step, this is the second way to get the product. Now this one, the product which we get from the first way, this is the major product, and the product which we get from the second way, this is the, this one is the minor product. This one is the minor product, that is here this one is the CS3, this is the CS2. So this is the minor product. Now how we consider it as a major product and it as a minor product? Because according to the Sedgwick rule, the case in which double bonded carbon contain the less hydrogen are preferred as a major, or it is also preferred as a stable. Now here the double bonded carbon atom is this one. This one is the double bonded carbon atom. Now it contains 1 plus 1, that is the 2 hydrogen atom. So according to the Sedgwick rule, the double bonded carbon atom which contain the less number of hydrogen atom is considered as a major or the stable product, whereas let us count the number of hydrogen atom here. Now this is again the double bonded carbon, this is the double bonded carbon atom. Now it has 2 plus 1 is equal to 3 hydrogen atom. So it becomes the minor product. So in major product, or we can also define it as a, in major product, the two alkyl group are attached to the double bonded carbon atom. One CH3 means alkyl, this is the alkyl group, this is the alkyl group, CH3 is alkyl group, this CH3 is alkyl group. So the two alkyl group are present on the, or attached to the double bonded carbon atom. Now look at here, this is the double bonded carbon atom, this C is the double bonded carbon atom, one CH3, this is the alkyl group, it is attached here, and this is also a double bonded carbon atom, so another alkyl group is attached here. But look at here, only in this position we have the alkyl group, we doesn't have alkyl group in this direction. In minor product, only one alkyl group is attached in one side of the C carbon-carbon double bond. So this is the Sergev rule, and by the help of the Sergev rule we can easily define the, or we can easily find out which one is the major product and which one is the minor product. So these are the very important property of the HaloAlkanes. And let us discuss one more topic. There is a line, that is a ambidentate nucleophile. If we are talking about the another topic is this is ambidentate, this is the ambidentate nucleophile, ambidentate, this is the A, this is the ambidentate nucleophile. So group like cyanide and nitrites possess two nucleophilic centers, and they are known as the ambidentate nucleophile. It means the ambidentate nucleophile possess the two nucleophilic, that possess the two nucleophilic centers, and they are known as the ambidentate nucleophile. देखो कितना होगा साना, देखो क्या, देखो कितना होगा, बंद कर, से कहाँ से बंद करूँ, स्टॉप का बटन दबा, इसको दबा, किसे, सी को, हाँ हाँ ये सी को